Below is the skeleton equation for the rusting of iron. All chemical reactions can be described by a skeleton equation. The skeleton equation describes how the particles of the reactants rearrange to form new particles called the products. The products must always be made up of the original elements described by the reactants. In this example, you see the products are made up of the iron and oxygen, just as the reactants are. When the chemical reaction occurs, the atoms or ions of the reactants simply rearrange and chemically bond in some new arrangement. The skeleton equation describes the correct chemical formula of all the reactants and products, but typically does not describe the correct particle or mole ratios needed for the reaction to occur. According to a very important law known as the law of conservation of matter, all chemical reactions must have the same amount and types of atoms as both reactants and products. The simple sketch below shows iron represented by the purple circles. It also shows oxygen represented by green circles. You can clearly see that there is only one circle of purple on the reactant side, yet two circles of purple on the product side. This clearly shows that an atom of purple or iron has somehow been created, which is not possible if only starting with one circle of purple or iron. Furthermore, it shows two circles of oxygen and three circles of oxygen on each side of the equation. Two circles as reactants and three circles as products. It's therefore very clear that one circle of purple iron with two circles of green oxygen could not possibly form what we see on the product side, two circles of purple with three circles of green. Therefore, we would need the correct ratios or quantities of these atoms for this chemical reaction to truly occur. The skeleton equation written therefore only describes the correct particles of the reactants or products in their formula version. It does not show the correct ratios. The correct ratios are revealed by what we call the balanced equation. The balanced equation shows the correct quantity ratios of all reactants and products. These quantity ratios are revealed by what are called coefficients. Coefficients represent the number of particles of each reactant and each product that would be necessary for a chemical reaction to occur. When looking at the particle sketches below, it is clear that we would need 4 particles of iron or atoms of iron to combine with 3 molecules of oxygen, and this would form 2 molecules, or more correctly known, 2 formula units of something called iron 3 oxide. This now turns into what is called the balanced equation and shows the correct ratios for all reactants and products in the chemical reaction.